In this goal, we're going to define and use the terms endothermic, exothermic, and activation energy. Let's start off with activation energy. Activation energy is the minimum amount of energy required to start a reaction. So you might need to heat your reactants together to get them to start to react. Maybe you need to add a little spark with a flame. Maybe just grinding them together, that friction can cause the activation energy to start the reaction. For example, when you go to react the chemicals that are on the tip of a match. So you use friction to rub those together, and then those chemicals ignite and it lights the wooden matchstick. Also, electricity can be used to start a chemical reaction, and light can also. Reactants yield products. Here is a specific type of reaction called an exothermic reaction. In an exothermic reaction, energy exits or is given off by the reaction. The products are at a lower energy level than the reactants. So I can look at the amount of energy and I can see that my reactants are at a certain level and my products are a lot lower. So where is that difference in energy? Where does that go? Well, it is given off in the form of heat. So heat will exit the reaction. So if this reaction was taking place in a beaker, I could put my hands on the beaker and I would feel that the beaker is warm or hot because heat is given off by the reaction. Let's look at some other things in this diagram. So we see our activation energy is right here. So this is the little start that it needs to start breaking the bonds and making them. And for an exothermic reaction, it tends to be a lot smaller than an endothermic reaction, which we will talk about next. Okay. Your activated complex is right at the top of this little energy hill. So once you use the spark or the friction to get the reaction started, then the bonds are going to start breaking and being reformed into your products. But right here at the top of this little hill, it forms that activated complex. Again, an activated complex is where the bonds are breaking and are being reformed. So again, this is an exothermic reaction. You can see it generally goes downhill. Exothermic reactions are quite common because we don't need very much activation energy to get the reaction started. This is an endothermic reaction. Again, reactants yield products. An endothermic reaction occurs when energy enters or is absorbed by the reaction. The products are at a higher energy level than the reactants. So again, here's our energy. Reactants start low and our products go high. And that difference, where does it come from? Well, it has to enter into the reaction from the surroundings. So if you were to have an endothermic reaction in a beaker and you put your hands on the beaker, it would feel cold to us. And why it feels cold is because the reaction is actually sucking the heat from our hand into the reaction. So that energy is being pulled into the reaction. That energy is being pulled in, and notice the activation energy. It's a lot higher than what we just saw in exothermic. So as a result, it's harder to get all that activation energy. And so the endothermic reactions in the world are few and far between, at least the ones that are spontaneous that will occur once you get them going. So again, large amount of activation energy. And then right up here, again, we have that activated complex. So the activated complex is where those bonds are broken and reformed. And they will be reformed into a product that is more energy than the reactants. So again, exothermic, heat is exiting the reaction. Endothermic, the heat or the energy is entering the reaction. Exothermic feels hot or warm. Endothermic feels cool to us because it's sucking the heat in from our hand.